Hello, this is Morgan Calzone, and this is my 7th 6th grade math help video. So we are on Unit 7, which is Geometry, and today I will be showing you how to do the area of shapes in composite figures and how to find the volume and surface area of 3D shapes. So we are going to start with area, and I have some diagrams with formulas on them to show you how to find the areas of different types of triangles and rectangles, squares, parallelograms, trapezoids, the usual shapes that you're going to be finding the area of. Also, down below here, I have an example of the kind of problem you would see in doing geometry. Okay, so one of the lessons y'all are going to have to know how to do is find the area of a composite figure. A composite figure is a figure that is made up of more than one shape. So as you can see here, it's a strange shape, but if you break it up, you can see it forms a triangle and a rectangle. Okay? So in order to find the area of these kind of shapes, we're going to find the area of each individual shape inside of that composite figure. So we're going to find the area of this triangle and this rectangle. Okay, now it's already shown here and it's worked out. So it shows you that the area of a triangle is 1/2 base times height, and it shows you the dimensions, which you'll have to find based on the figure. So you can see this length is 10 and this length is 6. So 6 plus 4 gets you 10. So you know that this has to be 4, this base of the triangle, and you see here that this entire length is 16, while this length is 10, so you know that 16 minus 6 gets you 10. So that's how you find the dimensions of this triangle, and they show that here. And so you know that the area of a triangle is 1/2 base times height. So you plug all your dimensions into the formula, and you get your answer. So you found the answer for the area of the triangle, which is 12 in this case, and then you go to the area of the base of the square, which is this base right here, okay? And then you figure out your dimensions. You see that this is 10, this is 10, so it's really a square, it just looks like a rectangle. So you're finding the area of the square, which is base times height, and so you have 10 times 10, because that's your base and that's your height. This is your height, this is your base, this is your base, this is your height, okay? So 10 times 10 is 100. So the total composite area of this figure, it would be 12 plus 10, or no, 100, because that's 10 times 10, which gets you 112. This is shown right here. Okay, so remember, you separate your composite figure into triangles and squares or rectangles, or other shapes that you know how to find the area of, because you can't do the entire figure to find the area of it because you don't know the formulas for a strange figure like that, so you have to break it up, and then you add the areas that you find for each figure inside the composite figure. So you found the area of the triangle and the square, which you broke up this figure into, and you add it together to find your answer, which is in this problem 112. Here are some examples. So we're going to do a triangle, a parallelogram, and a composite figure. So let's start with the triangle. We know the area of a triangle is 1/2 base times height. We see the base, which is right here, is 3. And we see that the height, which is right here, is 4. So 3 times 4 is 12. 12 times 1/2 is 6, okay? So now we don't have any units here, but if we were to say that it was units, we'd say units squared, okay? Okay, so the area is 6 units squared. I'd like to point out that it's crucial to memorize formulas because they will not be given to you on your test, most likely. So you need to know the formulas of your basic figures and shapes, okay? So now let's do this parallelogram. So I'm going to write in some dimensions, okay? So if this were 2, this were 4, and this were 7, okay? So the area of a parallelogram is area equals base times height. So now I gotta plug in our base and our height. Our base is 4, and our height is 2. So 4 times 2 is 8 units squared is our area, okay? So as I showed in the triangle and the parallelogram, we do not use this side or this side. These diagonals, we do not use those for our base and our heights, okay? Just know that. And so now we're going to do our composite figure. Now, the easiest way to solve our composite figure is to divide it into 2 different figures, okay? One figure is a rectangle, the second one is a triangle. And so we're going to find the area of our rectangle first, okay? So before we do that, let's find all the dimensions needed. We see that this is 15, but this is 20, so that means that this dimension right here is 5. Okay, does that make sense? If we were to draw another piece making this a rectangle, this would be 20. In order for this to be 20, this would have to be 5, because 15 plus 5 equals 20, okay? So that's how you get 5 from, okay? Now, we see that this is 10, so this must be 10 as well, this height, okay? So let's do the area of our rectangle first. The area of a rectangle is base times height. So we have our base, which is 15, because that's where we cut off. We cut this 5 off the 20, right? So this is 15. Okay, that would be like that if we cut this in half. See, 15 plus 5 is 20. So that's the entire length. We cut this part off for our second figure, which is a triangle, and then we have our rectangle here. So 15 is our base, and our height is 10. So we do 15 times 10, which is 150. And we have units, okay? The units are centimeters, so centimeters squared is the area of our first figure. Now let's do a triangle. The area of a triangle is 1/2 base times height. The base is 5. Remember, we divided 20 into 15 and 5. And our height is 10 as well. So 10 times 5 is 50, divided by 2, or times 1/2, is 25. So the area of our triangle is 25 centimeters squared. So now, finally, we add the 2 areas together. So it's 150 plus 25, and that gets us 175, but don't forget the units. Centimeters squared is our final answer. Now let's move on to volume. So here are some formulas for volume with the variables listed so you know what it's representing. So we have a cube, a rectangular prism, a cylinder, a cone, and a sphere. So what we're going to be focusing on are rectangular prisms, but we're going to be focusing in on solving problems with rectangular prisms, but using fractions as our unit. So here's an example. We have a half inch, and a 1/4 of an inch. And so we're going to find the volume of this rectangular prism. Okay, so as you see by the formula, the volume of a rectangular prism is length times width times height. So we have length, the length of this rectangular prism, this is the length, this is the length, okay, the length is a half, okay, times our width is 1/4 of an inch times our height. Our height is 1/2 an inch. So when we're multiplying across with fractions, we multiply across the numerator, and you should know this, the numerator, the denominator, you multiply across the numerator, so we do 1 times 1 times 1, which is 1, okay? And then we do the denominators across, so that's 2 times 4, which is 8, and then 8 times 2 is 16, okay? So this is our answer. And for volume, we do the units are inches cubed. So this is our answer. So here we have an example. Okay, so remember we're doing volume problems. And so the formula for volume is volume equals length times width times height. So we're going to do length, the length times the width times the height. So this is the length, this is the width, and this is the height. Okay? So we're going to plug this into our equation. Here we have 14 over 3 times 3 times 12 over 7. Okay? So we're going to change them all to fractions. Make sure everything's a fraction. So we're going to move up here so more space. So 14 over 3 is a fraction times 3. And to make this into a fraction, we just put it over 1 because 3 over 1 is 3. Okay, and then times 12 over 7. Now remember, we multiply across, so we do 14 times 3 times 12, and you can write this out because you want to be able to do it in your head, right? And so when you multiply it out, you get 504 for your numerator. Okay. And then for your denominator, remember we multiply across for the denominator as well. So that's 3 times 1 times 7, which is 21. Okay. So your answer is 504 over 21 centimeters cubed. Remember, volume is cubed. So the next thing we'll be doing is surface area. So here I have some formulas of some three-dimensional objects you'll have to be able to know how to find the surface area for. So here's some formulas for those. And then I have an example here. Okay, so we have a rectangular prism, and you need to know that this is the formula for it. Okay, so here I have the diagram already made, but there's a chance that you will have to make it on your own. So you have to know how to unfold the rectangular prism so that it's two-dimensional, not three-dimensional, which makes it a lot easier to solve for the surface area, because the surface area, what it really is finding the area of all the sides of this prism. So you're finding the area of this, 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 and this. And that's the total surface area. That's the same thing as finding the area of all of these sides. Okay? All of these sides. Okay? And so that's what total surface area is. And so we're going to find the area of each of these sections. So the formula is the same thing as that. It's finding the surface area for all of those sections, only it's written in a neat formula that you can use. Okay, so let's do this formula. Surface area equals 2 length times width plus 2 times height times width plus 2 times length times height. Okay, so we know that the length is 5, okay? The width is 3, and the height is 4, okay? And so that's how it is based on this diagram. So we're going to plug these in, okay? So we have 2 times the length. The length we said was 5. The width, which is 3. And we're going to add that to 2 times the height, which is 4, times the width, which is 3, plus 2 times the length, which is 5, times the height, which is 4, okay? And so what you're going to have to do is multiply it all out and then add them all together. So let's do it in sections. So we're going to do 2 times 5 times 3 is 30, plus 2 times 4 times 3, which is 24, plus 2 times 5 times 4, which is 40, and then you're going to add all those together. So 40 plus 24 plus 30 is 94. So the surface area is 94. And because it's centimeters, okay, it's centimeters squared. Just like how when you're finding the area of something, you square your units. It's the same thing with surface area, because it's also area. It's just the area of a three-dimensional shape that you transform into a two-dimensional diagram that then you solve for the surface area of that diagram. Okay? So here we have our example. Okay, we have our rectangular prism, our 3D rectangular prism, and our net for that rectangular prism. Okay, so first we're going to write the area, the surface area formula, yep, for the total surface area of this prism. And we're going to use that net diagram to help us figure it out, okay? So we're going to do 2 times length times width plus 2 times height times width plus 2 times height times length. And this is our surface area formula. Now we're going to categorize each number to represent length, width, and height. Okay, so 3 is the length, 2 is the width, and 6 is the height. Okay, so we're going to plug these numbers into this equation. Okay, so 2 times the length, which is 3, times the width, which is 2, plus 2 times the height, which is 6, times the width, which is 2, plus 2 times the height, which is 6, times the length, which is 3. And now we're going to multiply each section and add them together. So 2 times 3 times 2 equals 12. 2 times 6 times 2 equals 24. And 2 times 6 times 3 equals 36. So now we're going to add these all together. So that's 36 plus 24 plus 12 equals 72. So the surface area equals 72 centimeters squared. Now remember, area and surface area, your units will be squared. Volume, your units will be cubed. Now it's time for our geometry recap. Remember, for area, memorize your area formulas, okay? That's very important. Remember, break down the figures, the composite figures, into triangles and rectangles, so it makes it easier for you to find the area, okay? And remember, for area, the units are squared. So if it's centimeters, if it's inches, it's always squared, no matter what the unit is, okay? For volume, memorize the formulas. Once again, it's very crucial to memorize those formulas. When finding volume with fractions, plug in the fraction to the correct place in the formula and multiply the numerator across and the denominators across. So remember, you're going to multiply the numerators across and the denominators across. So if this was an example, you had to multiply that across. You'd multiply the numerator across, so you do 1 times 1, which gets you 1. And then you do 2 times 4, which gets you 8, and that'd be on the bottom. Okay? So you multiply across. Okay? And remember that for volume, whatever the units are, whether it be centimeters or inches, it's cubed, okay? So it's cubed, not squared like area, it's cubed. Now for surface area, remember, memorize the formulas of surface area problems, draw the net diagram, you need to know how to do that, and find the area of each individual shape in the net, and then add, or just use the formula, okay? Remember, surface area, no matter what the units are, centimeters, inches, it could be something else, it's squared because it's surface area. Area, area. That's, and volume is different. You cube it. Okay, so I hope this video was helpful. I would love some feedback, and until my next video, hope y'all enjoyed it.